Okay, question 7c. So it tells us that the fission of one uranium releases 203 mega electron volts. Determine the maximum amount of energy in joules released by 1 gram of uranium-235 as a result of fission. So the first thing I'm going to do right now, and the first mark you would get for this, is simply converting your mega electron volts into joules. So remember that mega means times 10 to the 6, and electron volts is 1.6 times 10 to the minus 19. Okay, joules. So all I'm going to simply write down for my first mark is 203 mega electron volts, okay, multiplied by 1.6 times 10 to the minus 19 times 10 to the 6 gives me 3.248 times 10 to the minus 11 joules. And so I don't forget, I'm just going to write this as for one nuclei. All right. The next stage, we're going to know how it is for one nuclei, but now I'm looking at how much has been released for 1 gram of uranium-235 as a result of fission. So I want to work out how many nuclei I have in 1 gram of uranium-235. Okay, so again, I like to sort of write down things to the side that I know, and sometimes my equations, just to keep my workspace kind of nice and clear. So I've got 1 gram. I know that my relative atomic mass, okay, is 235. I also know Avogadro's constant, okay, 6.02 times 10 to the 23. And then I can remember my different equations for working out my number of moles. Okay, so we've got number of moles is equal to the number of nuclei over Avogadro's, and also the number of moles is equal to the mass divided by the relative atomic mass. So I can also use this equation here to work out my number of nuclei. So I'm just simply going to say here that the number of nuclei is equal to Avogadro's times the mass, all divided by the relative atomic mass. So in this case, that's 6.02 times 10 to the 23 times 1 gram, and then divided by our 235 grams. And that gives us approximately 2.56 times 10 to the 21 nuclei. So that's again your second mark, is an approximation of working out how your nuclei is done. The third mark is by multiplying these two values together. So I know how much energy I get for one nuclei. I now know approximately how many nuclei I have. So my final mark is then just working out how much in total the energy would be. So if I do 3.248 times 10 to the minus 11 multiplied by 2.56 times 10 to the 21 gives me 8.38 times 10 to the 10. Okay, or 8.38, that should say 8.32, sorry, I can't read my own writing, joules. And again, if you'd messed up maybe here getting this one wrong, as long as you had this one here and then multiplied it by this one, you got the final mark for the one there by recognising what you were supposed to do.